into third quarter. So I'm just going to collect your stuff as we end the quarter. Before we go, so we're hoping that on the 13th, and I got to talk to 8th grade about Winterpalooza, we're hoping that all of 7th grade is mastered, and we do kind of like a Winterpalooza thing with them, but I'm guessing I don't see you next week. Or 8th grade, we don't have math. If I see you, if you have class, we'll do mind track or something fun like that.
So this is like the 1 to 3, 4.
So, on Tuesday of next week, I'm going to collect, if you're using like a math journal, if you use a binder, wherever you keep your math stuff in, I just want to review it. I want to look at it, check it out, see how we're doing. Ladies and gentlemen! That's all I need to say.
So should I put this back in my binder?
I didn't lose class.
Should I? Try it out. Oh no, wait, you do plus. What's inappropriate things that you guys are doing right now?
Oh, I don't know. I think this is golden. I'm not sure. Talking about this right now is a very poor choice. So I'm going to end this conversation. You make whatever choice you want. Sorry, this is not a middle of class conversation. All right. First things first, for my people too stressed out, and one thing you got to learn in life is there's things worth being stressed out about and things that aren't. The ACT is probably worth stressing about. An air test is not really worth it. So, this is the Ohio State student practice site for air tests via the 9th grade. If you wanted to get here, let's close it and act like we weren't there. From Schoology, our Math 2 page, right here, link says air practice site. Also, right where we were yesterday, programming the calculator. If you go here, I'm going to show you this first because I think it's cooler than talking about the air test. This is the basis of their website. If you come up here, this is what we were using, quadratic equation. But if you want to back up, click on the TI-8384, and you can look at all the different things that they have programs for. So if you want to look at different trig or calculus or whatever, that will help you write the different code.
By the way, the date today is very interesting.
125. What?
12, 5, 6.
You are right. No, that was good. That was good.
Why?
Then, all right, hold up. I don't know what happened to this image. Then, air practice site. So, Ava, you should be looking since you care about this.
Okay.
Air practice site, click on it again. Here's the thing that most people get goofed up about. You just click sign in. Everything's going to say guess. You've got to click a grade. You're going to lie and say 9. You're going to lie. Well, you could, but I don't know if it'll come up with Math 1. From here, it generates, oh, you're in the 9th grade. What class could you be taking? So, depending on your school and the track they took, they could still call classes algebra geometry. We don't. So, you'd be looking for integrated Math 1. Notice they have a practice test. They have from spring of 16 what was released, and spring of 17 what was released. All of these resources are great ways to review. They have paper tests. The problem is this item cannot be rendered as a paper pencil. So some of them can be rendered as paper pencil. Some of them cannot. So I would just go on here and look at their practice site and choose a test. And you can decide your settings. And then okay, whatever, skip this. Begin test. You gotta do some clicking. Then you check out the test one. So it does a lot with functions. Every input has an output, all that stuff. So I would review this, Google up what you're having issues with, or come talk to me. I'm not going to do whole class review because we're not all taking the Math 1 test. We did this over the summer. I know those of you that took the summer class, it's a rush course. But this, I don't like calling it an exam. This thing, I don't even want to call it an assessment, is fairly mild on how deep it goes. And it's not a big deal. Let's, I don't even think there's any questions on here about that. So we can talk about that. We can figure out an explicit and recursive, but yeah, you guys should look through and check that out. So let's explicit versus recursive. So examples of explicit versus recursive. We've done mainly explicit formulas, where you say the output of the function will be, like, I don't know, 3x plus 4. All it does is use the input. It explicitly does something to the input, some things in some cases, you get your output. Recursive has to reuse a previous value. So then we start to say a sub n, a being the value, n being the term number. So a sub n here, if we write this as an explicit,
excuse me, can I please have Wyatt to the office?
Is now 3 times n plus 4, because it's 3 times whatever my input, my step. We start to call those explicit recursive. We're saying, like, what step am I in, what stage? If I wanted to make some kind of example that was recursive, I would need to say a sub n will be something like 2 times a sub n minus 1 using a previous term in the sequence to double the thing you had before and then do something. Or just double the thing you had before. So we're going to talk about, like, we can kind of write this as like an exponential. So we could say an exponential is going to double every step it takes. This will double the previous value every step it takes. So this is just a different way to write it because it's saying take the previous term, double it. But the problem is you need to know the previous term. So when you use recursive, you'll almost always need to be told what is a sub 0. Where do you start? Where's the origin? What value do you start at? So that a sub 1 could then double this value. So a sub 0, the original step was 2 rabbits, and then the population starts to double. Well, okay, if I double my previous, I get 4. If then I double my previous, I then get 8, and I would start doing that, and it actually becomes exponential. We could rewrite this as an explicit, but actually turn into exponential. You've experienced more functions and done more, and it should. So I'm glad to hear that. But this is why I'm trying to alleviate your concerns. Like, if you just do a bit of review, Google up those words that you can't quite remember what they mean. Like, if you look at a few examples of these, like, I'm not the best math person out there. I'm not even I'm just a decent math teacher. Google. There's really good resources on Khan Academy, Cool Math something. No, don't go to Cool Math Games. There's like, right, but there's a different website. I've got a few of these on my Schoology page. So if you go, and I think it's near the bottom. Maybe I still need to post it. So I've got a folder of different links and notes in my Math 7. At least I should be. Maybe I'm wrong. But if you check with me, I'll tell you which ones are good. Most of them are good. If it looks too flashy and crazy animated, it's probably not that great. The simpler websites are sometimes the best, actually.
Because they have good content.
trying to remember. Oh, Purple Math. Purple Math is actually a really good website. Seriously. So look at how simple this website is. But if I search for anything over here, like let's say recursive.
What could it be?
Recursive sequences in series, like very straightforward. Okay, give it more words if you want a more in-depth search, like refine your search. If I go look at recursive sequences, it's going to break it down for me. What's your A sub 1? What's your A sub 2? How do we start to write this? So use your resources. Any other huge concerns about that before I move on? All right. So this homework is not necessarily needing to be done today. We're going to take at least a couple days to talk about 5.2.5. But let's make sure we were comfortable with 5.2.4. We talked about how to solve these. We were in the middle of programming our calculators. Anyone's programs stay there? Anyone check? If you still have a program. Hit PRGM and then see if there's still a program there.
Yep, friends is still on here.
So it's probably been cleared.
Garrett. Guys, who named theirs Garrett? What?
All right. So moving on to 5.2.5 though, we'll come back to coding if we want to, but we don't necessarily have to do that since we know the quadratic equation now.
Mine's messed up.
So
Sorry for the interruption. Could I please have Sky Everett to the office? Sky?
I want you to play with some situations. Right, so we are dealing with quadratics in standard form, which I hate when they call things standard form because that's used like 9 different times. But standard form for a quadratic is this, right? But what if it's not like that? What if terms are missing? Or what if there's other things going on? What would you do then? Can we still use the quadratic formula? Is there a situation when we can't use the quadratic formula? Why might that be true? So talk with your team about what we figured out yesterday with the quadratic and when you think it might fall apart. Or what could we just state about, well, we physically can't do the math if. So talk for a couple minutes. If you can't find a jumping off point, you can check out the examples down here, like A, B, C, D, E, like there's a bunch. So you can check those out if you can't find a starting point.
But even more specific, you don't need to have the terms be X. Yeah. So really the only thing I did what? Quadratic.
You guys could let me finish the sentence first. If your discussion is fizzled, yeah, go ahead and try to solve A through that. I'm going to give you a few minutes. Work on solving A through F. Try to use multiple strategies. Maybe somebody at your group really likes the quadratic, and they can type it in their calculator fairly quickly, and then edit that as you go. Maybe somebody really likes solving it using zero product property. Try some different methods.
Do you guys want to like solve like we have three people, so like I could do like A and B, you could do C and D, and you could do C and F.
Sorry, that's what we were
We
doing.
can talk about that. No, like what method are you using?
Two.
Hey, actually, I have
I'll
it.
do A and D. Yeah, you can do C and D and
That's what I
unless
should
you already started on A.
see if we can remember what the tune is.
What? Comparing a perfect. Okay, then I'll do C and D. Yeah.
What song is this? Yeah, it's All Around the Mulberry Bush. Yeah, so that it goes to All Around the Mulberry Bush.
The song that sounds like a bunch of demonic satanic children.
Ooh. Ooh.
Oh, no.
What? Hold on,
We try to
Greg.
get work done with it, we just kind of
If you try to solve a quadratic equation,
You
move it to one side, so
Die.
X and the rest. Alright, no technical addition. Name them A, B, and C, and if you know the right formula, you will see that you get the solution in the very next step. Just sing the song in your head.
His lip syncing is good.
Plus or minus the square root of B squared minus 4AC over 2A.
I think this makes it harder to remember. B squared minus.
Okay, let's solve our equation. And that's
All right, challenge. Make a better quadratic equation song.
Okay.
Although, dude has got 170,000 views on this.
Yes, we both did on that idea.
Dude, this guy has 600,000 views.
If you have a million,
It's the same person. You can edit it. We called dibs on that idea for sure.
I am Wait,
Not one.
I don't think.
It's not in English.
Yeah, it's definitely not.
All right, back to what we're supposed to do.
Discovery Day ideas.
We could just do negative X.
Just make a ton of songs for math formulas.
Yes, I already got one.
Hey, skirt.
I'll go ahead and put that link for the one we were just watching with the nice drone footage of the mountain. I'll put that on our Schoology page in case you guys just really want to show that to all of your friends.
Yes.
Hey, it's gonna go on the updates page, so it's just like. Well, here, I'll put it as a real link.
No, that song.
All right, that's pretty great. Go give that guy some hits. Feel count and blank.
Oh, come on. That sucks.
What notice A?
No, A's really easy. Just use the factor again.
Plus 9.
X plus 9 times X. For B, I'm trying to use the I'm trying to use the quadratic. Is that you? I heard that.
Syntax is my oldest enemy.
Everything's your enemy. If you both said it, it's like wrong with you. I think I did something wrong too, but it's okay.
Always
Yeah, you gave that.
Yeah.
I got X. Well,
I don't like this method.
Which method are you using?
Using the quadratic.
Can we just do that? Can we just do it like by hand?
And yes.
A.
If it's simpler numbers, sometimes it's just easier to do by hand.
Wait, so am I going to see
X plus 6.
Oh, I forgot where else. For
I shouldn't pick up green pen.
No, Ava, don't believe in yourself. Believe in the me that believes in you.
I'm trying to do that method in a weird way.
Why? Negative 2b plus or
No.
minus the square root of b squared minus 4ac.
I already forgot that whole song.
Yeah, me too.
Don't worry, I'll play it again at the end of class.
Yes!
I'm just gonna say negative b plus or minus the square root of b squared minus 4ac.
So crappy.
It's easier. Nobody needs to sing me.
It's not music class.
What?
It's going higher. Nowhere near this.
I heard me.
No.
Me?
Lavanda.
Yeah, how do you do B? Oh, okay.
Did you see it? See it? What?
I think you're right.
Ooh, 36x squared.
Yeah.
That sounds fun.
It's fun.
Ooh, fun. Oh, I see something there. Wait, no, I don't. Oh, wait, yes, I do. No, I don't. Yeah, I did it.
Okay, what do you
You. You don't know an easy way to do A, or what you think is the easier method, Jenny? Which
No.
method are you using?
just factoring.
So, like zero product property, then you're trying to get the two factors and solve your zeros from that point. So you're looking for values that add 12 and multiply to 27. So we're gonna, so they're both gonna have to be positive. And you figure out 9 and 3, which makes your zeros -9 and or -3. Wait what? Are we good on A? You could also, again, remember this method, where you're trying to find the sum and the product and find your values here with the 9 and the 3. You can also use that, remember. So let's look at B then. Anyone have an easy method for doing B? Yeah, you. What do you mean the factoring?
The quadratic formula. The quadratic formula.
Okay, so we could use quadratic formula, but we're missing something. Right? What don't we have? We're going to use the quadratic formula and plug in. We have 0 as our B value, right? So if we do that, we're plugging in 0 for B. There's another easy way to do difference of squares problems. Remember, this is one of our special quadratics. Has no B term, means a difference.
Is this the square root of the constant?
Close.
Plus or minus?
Yeah, it's 2x plus 11 times 6.
It's what? Are you trying to give me the solutions or what?
The solution.
Oh, you.
Wait, am I wrong?
Where are you getting 2x? Where are you dividing or something? Oh, so you're doing, yeah, which is totally fine. Sorry, my brain was just going a different direction. So you're doing, this has to be plus this has to be minus, and then you find your terms by, or your constant values, square root of. Now that still leaves me to do a bit of math. Because to find my zeros, I know they'll be the same, positive or negative. But then, what is it? How do I figure that out?
I thought it was 11. I didn't know what I was doing.
No, because 2 times 6 is 5, right? No, wait, no, 5 plus 5, sorry. No, no, 5.
I mean, I just said 2 seconds ago.
Ethan, why did someone need a calculator for that?
All we would do here, give me your attention for just a second. All we would do here is set each of these equal to 0 independently. So if 2x plus 11 equals 0, I'm fairly confident we could all solve that. We subtract 11, then we divide by 2. So when we have a coefficient inside our parentheses and we're using, so you're still using zero product property. You set up my products, we got to figure out when they will be 0. 2 different situations, positive or negative, 11 over 2. The other way we could do this, because it's difference of squares, isolate the x by working your way there. Then we would divide by 4, and then we take the square root, which ends up being positive or negative 6.5. This is 30, sorry, 5.5.
Wait, you did.
You said 6.5, and now it's in my head.
Did you do the
So
same thing?
this is 20, no, 30 and a quarter.
Yeah.
Yeah.
Long division struggles. Questions? Good? 2 different ways?
Yes, confusing.
What? No, you
Okay, do you understand a way that you would solve this?
Yes.
Okay, that's what matters. We all have different brains. We're all going to solve things differently. Do not feel like you have to do it the same way as your peer.
But society condones it.
So here, we can solve it real quick if we utilize what we were just talking about with Jenny's zero product property. We know that if this 3 wasn't there, we would just have x equals negative 4. But since that 3 is there, we would have to divide by 3.
Oh, okay. So,
Wait, what?
So, again, if you actually utilize the property and say 3x plus 4 is 0 at what point, you'd add 4, or sorry, you'd subtract 4 from both sides. Then you'd divide by 3, and you get x is negative 4 thirds. We can get there more quickly by just thinking through, if this didn't have a coefficient, we'd just have negative 4. Because it has a coefficient, that has to divide by 3. Well, because the coefficient is 3. So over here, my x that would make this true, if the 2 wasn't there, would just be positive 1. But since the 2 is there, positive 1 half. We divide by that coefficient in the parentheses. Now you could just literally set it up and solve it, but you will get quicker and better at this, where you do not need to even think about this. Questions? Because I have a lot of quiet people. Does this make sense? I'm gonna pull one out of thin air and see if we actually are lying to me or what. If my solve the zeros for that. This would be ridiculously ugly, but we can zero it out real quick. What's my 0 from inside this parentheses?
negative 7.
Opposite,
Yeah.
7 over 13. Yeah.
7 over 30.
Yes, I said it. I didn't write it. I don't know what's going on with my brain. 7 over 13 over here, opposite. Negative 13 over 7. Yay, prime numbers. Okay.
What was that?
D. What do we need to do first? Move the values. Okay, so D is pointing this direction. So this will become. I hate when you can hear your phone vibrating. It's just because it's on my desk. I normally have it on like something soft. X squared minus 8x. Right. Then we have a positive 12 that we would have to add the 4. And we get positive 16. That's not mine. Those go in Pettigrew's room, I think. And she's got like a little vertical container that would go on a bookshelf. Yeah, she can show you. X minus 4 squared. So x is just 4 or 4, so it's only 4. I said that like 4 times.
I know,
They
but
don't know that we ever will. It's not a standard that you need to learn. It's just something I'm going to show you guys is possible.
It's me. That's all.
Learning how to write code is not a mathematical standard. Knowing that your calculator can code is beneficial. And you could write whatever code you want to. Like you could invent what like it to do something. Like you could write a code for like if I have this much laundry to do, how long will it take? Like you could write any code you want.
I told my brother that we were running calculators that you can code whatever you want, and my brother's like, "Can you code it to like speak to you?" And I was like, "No, I don't think so." I don't know why
It doesn't have speakers.
Exactly.
Jamming on my calculator. So if I make this quadratic, I think most of us would have done that first. So I need your attention on this one because I bet some of us did not solve this because the large coefficients
Big bet.
are scary.
Ocean bet. Big bet.
Now, what should we notice right off the bat? 36 is a perfect square.
It's 25, so that makes it a lot
25
easier because
is a perfect square.
factor and make it all work out.
So how do we factor and make it all work out, Jenny?
Okay, well, since we have negative 60, we know that 60 divided by 2 is 30. Okay, you know what?
So if, go ahead.
Okay, so 36 factor that to 6 and 6. Well, 6x and 6x. And then 25 factors that to 5 and 5. So when you multiply those two together, they both add up to 30, but one has to be positive and one has to be negative. Wait, no. Both have to be negative because, yeah.
Remember, a difference of squares trinomial where one's positive, one's negative won't have a b term. They cancel each other out.
Yeah,
There's
right,
the val.
you're confused because like then you would have just written 1 and just play the square next to it.
Because we had to get to this point first before we could say, okay, it's a perfect square.
Well,
You didn't tell me to just write one. 6x minus 5. So now hold on. Still, we got to find our 0. It would be x equal to 5, 6, right? Opposite divided by the coefficient. Questions? This should be starting to flow a bit easier now.
Euler's number is weird.
Last one. Take a moment if you haven't done it yet. Whoa. Are you guys getting a constant of negative 75? Did I write something down? Oh, that's 30x. I made a mistake. This is 30x.
Exactly. I was confused.
I thought that looked really ugly. Now this sucks. Because 20 is not a perfect square. 45 is not a perfect square. Yeah, then my constant's going to become like weird, like 11 and a fourth. I mean, sure, we got nothing better to do. So 5x squared minus, what's this become? 8x minus 11 and a quarter now. Okay, sure. I don't know how that helps.
That still equals 0. At least.
Well, yeah, this will still equal 0. Wonderful.
It's smaller numbers now, so it makes it helpful.
Next thing is, do you have a scissors?
Square root it? I don't think that's going to help anything.
Are you sure?
I really
Hey, guys!
don't.
Challenge! Push these things.
Because if you try to square root these numbers, it's going to get bad. Somebody start trying to use the quadratic. I mean,
I don't like that. We need to code our calculator.
now, remember, if you aren't trying to do it all in one fell swoop, think it through, write it out, and only use the calculator to do what you need it to do. So if I think about the quadratic, even I'm going to use these numbers because they're smaller. Right? I can use whatever I want, but these values are smaller. If I go negative b, that's 8. Plus or minus radical b squared. Okay, that's 64. I can do a lot of this in my head. Minus 4 times a times c. I might as well write that out for right now. I'll compute that in a moment. All over 2 times a. Okay, 10. That wasn't that hard. Then compute a little bit more. Okay, so this is negative 20. Negative times negative. That'll be positive. If I do 10 times this, I just bump the decimal. So then I double it. I get 225.
What?
I'm just doing this multiplication kind of in my head. But if you, so this is 20, right? Make the 20 10 for a moment, which just moves your decimal. Then double your 112.5, which will become 225. I bet if you do this multiplication, I mean, I don't guarantee because it's. So we would then have 8 plus or minus radical 64 minus, sorry, plus because the negative negative. So then we can think about this momentarily. That's 289. Is there a perfect square of that? 17. So even writing it out and doing it manually, we just get 8 plus or minus 17 divided by 10. Mic drop. If you had asked me if that would ever become a thing, I would have been appalled when I was a kid because I was trained very carefully to take care of audio equipment. Dropping
If
you drop a mic, you can very highly damage it.
Yeah, no kidding.
The fact that saying mic drop is like a thing just hurts me. Well, like in reality, like you're just joking. That's one thing. But if you actually had a mic, if you're gonna mic drop, you need like a mic catch.
Yeah.
Somebody beneath you.
I thought you should have a cushion under it.
Actually, gonna drop my mic.
A pillow just out of sight somewhere. So if we add this, hold up, let's wrap this up. Hey, let's wrap this. If we add this and then divide by 10, what do we get? 2.5. We subtract this.
Or negative.
Negative what? 0.9. And that's it. Probably would have taken me almost as long to type it all in your calculator. When the values are easier, or when we can make them easier. Because notice, that's not what we started with. We had to divide by 4 to get there. Remember, that just affects the steepness of my parabola, not where the zeros are. So the zeros aren't affected by us momentarily taking a less steep version of the same parabola. Well, not same problem, but same zeros. Alright, we're out of time. Start this homework. You don't have to finish it. We're picking up this lesson again tomorrow. Okay? Yeah, they went really fast, right? We were just Connor was like, wait, we're done. I saw that look at the clock going, wait.
No, pi squared. Pi squared, not pi. Not pi.
Thank you.
Pi to the pi.
Hey, if you guys want calculators before the Math 1 people take them, just come grab them and like break. You're allowed.
Dividing all by 4. Divide everything by 5.
At least that's what it was in the past. Thank you.
Song.
We forgot to
Memorize the quadratic equations so you just
Okay, no, it's not really. Except for like this.
I was this close to
No, oh, can't leave.
song, you know you're
No, oh, it's not.
I'm missing a calculator. Black one. Oh, I have it.
Oh, yeah. Oh, what? I don't know what you got rid of that. That is real fun. Buy it on iTunes, guys. I don't like that. That was wrong. The best song.
Dude from the Netherlands or somewhere. It's like he's dropping so much math, so like it's all really good, but he's dropping so much math so fast.